Hello, everybody. This session is about Entity Framework Core. Maybe you have noticed that a couple of weeks ago, Microsoft released a new version of .NET Core, .NET Core 2.0 Preview 1. And together with this new runtime, there are also published new versions of libraries. So you can find or you can try ASP.NET Core 2.0 and also Entity Framework Core version 2.0 Preview. So in this session, I'd like to show you what's different in Entity Framework Core and good old Entity Framework 6. What are the changes? What are the differences? What's new? What's missing, and what remains the same. My name is Tomas Herceg. I'm from the Czech Republic. I'm Microsoft MVP and Microsoft Regional Director, which means that I travel a lot and speak on many conferences and tech events, user groups, and such things. And I'm also running a company called Riganti, which has about 60 developers, and we are doing consultancy services and also building an open source framework which you can use to write modern web apps without writing too much JavaScript. It's called .vvm. So what are we be talking about today? So the first we'll look at the reasons why Microsoft came with a new version of Entity Framework, what the fundamental changes, what's inside. Then we'll look at the features of this new library. Then we'll look at some demos. We will see how Entity Framework Core works on Windows and also on Linux with various database providers. And then we will mention the roadmap, what's planning, what features are still missing, and how it works in production, if it's ready enough for production deployments. So what's Entity Framework Core? It's a new library. It's not just a new version of Entity Framework 6. It's the original name was actually Entity Framework 7, but it would cause a lot of confusion because it's not an incremental release which could add more features to EF6. No, it's a new library. They started from scratch, and it's much more lightweight. It's extensible, and it's cross-platform. It works on both full .NET Framework and also in .NET Core on all platforms, including Linux and Mac OS. And also it should work on mobile devices if you are using a universal Windows platform. So even on mobile or tablets, it will work. So the original name was Entity Framework 7, but Microsoft decided to change the name because it's not EF7. It's a different library. It's side by side with EF6. It's not an evolution. They didn't only add new features. It's a revolution because the fundamental concepts have been changed. So the reasons why Microsoft started from scratch with this library is, there are a couple of reasons. One of them is that the Entity Framework is kind of old library. The first version was published in 2007, which is more than, it's 10 years today, and it took them some time until they developed it, so maybe the code base can be 10, 11 years old. And it wasn't portable easily to .NET Core, so there are many things that are just not present in .NET Core. And also, if you tried the first version of Entity Framework, there was a different API that is commonly used in EF6. Maybe you remember the old object context class. There was some nice tooling in Visual Studio where you connected to the database, generated a diagram, and it generated a class which derived from object context. And after a while, they came with the version 4.1, which was distributed through NuGet. It wasn't part of .NET Framework. It was separate library. And it suddenly started using a different API, the DB Context API. So the Entity Framework contains two APIs to do pretty much the same things. And what is more, the DB Context API has some features which are not available in the object context, and vice versa. In the object context, there were some features that were missing in DB Context, and you just needed to drop to the old API. So also for the cleanliness of the code, it's much better to start a new library, because if you already have two different APIs for the same thing, it means that maybe you should consider rewriting the library. And maybe if you did somebody use the syntax from the last line? Okay, 1 or 2, 3 people, 4. Okay, so that's the integration, because on the background there was still the old API, the still object context, and this object context adapter interface could convert the DB context to the object context to provide you with some functions which were not available in the DB context. So this nasty piece of code was, it's another sign that this library should be maybe rewritten or redesigned. Also, the problem of Entity Framework is that it's too monolithic. It's one library, and it's very difficult to extend. For example, in SQL Server 2008, there was a new, very nice data type called hierarchy ID. Who of you have used hierarchy ID? Okay. 2, 3 people. So it's a nice data type which allows you to create hierarchical structures in your database. But Entity Framework never supported this type. There was one guy who actually extended Entity Framework with this feature and created his own NuGet package, Entity Framework with hierarchy ID. So if you want to use it, you can try this package. You can, if you look on the, it was not on GitHub, it was on Codeplex. So if you look at the Codeplex, at the change sets he needed to do, it's about to change about 30 files, and in most of them you will find some switch. If the column data type is integer, do this. If it's decimal, do this. If it's datetime, do this. And he just added a new branch. If it's hierarchy ID, do this. Yeah, so the library is not easily extensible. You cannot just write some plugin. You have to edit a lot of switch statements on many places. So that's the monolithic design. It's not modular, so supporting new data types is almost impossible. And also, if you want to use the old Entity Framework in mobile environments or in containers or on environments with limited memory resources, that's also not pretty much, not that it's not possible, but Entity Framework was never designed to consume to work in low memory environments. The memory just wasn't an issue, so whatever it takes, just give me the SQL and my data. Yeah, so the new Entity Framework core is designed to work also in low memory environments. So that's the reasons why Microsoft started with a new library. Not that they rewrite everything from scratch, they may use some pieces of code, but still the EF core is the library, the structure of the library and the fundamental things are really different. And there are also new features which were not available in EF6. So in the Entity Framework core you can find, for example, batching. If you insert many rows, it won't create SQL command for every record. It will just create a batch. Additionally, they announced support for also non-relational data stores. It's not working yet, But Entity Framework Core was designed to support also non-relational databases. So if you have a very simple application with only several records, you can use, for example, Azure Table Storage. It's not good for querying. You cannot filter by every column and sort by every column. You have to be very careful how to design the schema, the structure of the table storage database. But if you have something very simple, you can use, or you will be able to use Entity Framework Core for querying Azure Table Storage or Redis or another non-relational databases. Also, who tried to make integrations or unit tests using Entity Framework and mocked the DB context in memory? Okay, so that's quite a lot of people, maybe 20%. The new Entity Framework Core contains the in-memory provider, which is part of the default distribution, so you don't have to mock it out by yourself. You already have a provider which is prepared for this task. There is one thing that you should always remember. It's good for testing some basic scenarios, but the memory behaves differently than SQL database. So don't rely on those testing. It's very important part of testing, but still you should have also integration tests running against real database, because the memory behaves differently. If you compare strings, in memory, it's typically it's case sensitive. In database, it's driven by the collation specified on the column, or the null values behaves differently. And also, in-memory provider doesn't check the referential integrity. So if you insert some record with ID referencing another table, and there is no corresponding record with this primary key, the in-memory store will be okay with that. There are no constraint checking. In real database, the code would just crash, but in memory, it will work. So it's not 100% accurate, but still it can help you by testing with testing the application. Another new feature is alternate keys. In Entity Framework, if you created a relationship, you could only reference the primary key. I have the table named orders, and you can see there is a column called user ID. And if you want to reference a user table, so the user ID must point to the primary key of the table. It cannot point to email address or anything. Even if it's unique, you only can reference the end of the relationship can be only the primary key. Alternate key means that if you tell Entity Framework Core that the email column is unique, you can have, instead of user ID, you can have user email column in the orders table. I think it's quite an interesting feature. I won't use it in every table, but once, twice per database, you can find it pretty convenient. Typically, if you have some the users table where username is unique or email is unique, you can use this in relationships. Also, the querying mechanism and query infrastructure was changed. In old Entity Framework, if you write a link query, the provider had to convert the whole query, the entire query, in SQL. In one SQL, and the infrastructure didn't expect some sophisticated things. Entity Framework Core changed the internal limitations, so the provider itself can decide what to do with the link query. So the provider gets the link query, and it can split it to several smaller queries and combine the results in memory, or translate only part of the query to SQL and do the rest in memory. Yeah, so the infrastructure inside Entity Framework is designed to support also these scenarios. And one feature that is already available and you can use is called client evaluation. And it it can do this. If you look at the query, there we are starting with the products table and filtering, so I'm interested only in products which are not discontinued. And in the select clause, you can see I'm calling a function. This function cannot be translated in SQL. Entity Framework cannot look inside the function because it's a normal function. It's just a piece of bytecode in memory, so you cannot translate this easily to SQL. But Entity Framework can see that he needs only the items on stock property, and then he can call the function after he obtains these values from database. So the Entity Framework in this case will just fetch the name and items on stock values from the database, and the getDisplayText function will be called after Entity Framework core gets the results, and he will build these objects. Yeah, so that's one of the features that's available thanks to the mechanism I've described previously, because the provider doesn't have to convert the entire query into SQL. It can split it and evaluate parts of the query in memory after it gets the results from the database. So this is a pretty nice feature, but it can be a little dangerous. You have to be careful. As in many other situations with ORMs, you have to be careful. It can slow down the query a little bit. Not that it would trigger lazy loading, because currently in Entity Framework core, lazy loading is not supported yet. But if you change this function, so there is only the P variable, so you have to give this function the entire object, entire record, and the function only uses the items on stock parameter, then it would be slower than necessary because you are fetching much more data than you actually need. Yeah, so be careful if you are using this feature. Use it only at the end of the query, in the last select clause of the query. If you use it somewhere in the beginning, then the rest of the query is done in memory, which can fetch much more data from the database than you actually need. If you do client evaluation here, then the where condition is evaluated in memory, which can mean that you get 1 million of records from the database and then filter out only 10 you actually need, but you are transferring a lot of data which you will not use. So make sure that you are using client evaluation only in the last select clause, and make sure that you only request data and columns which you actually need, because otherwise it would be inefficient. You can turn on logging, so if you look in the output window in Visual Studio, you will see warnings that client evaluation happened. Sometimes you can use client evaluation by mistake, so make sure that you check these warnings, and if you didn't want to use client evaluation and you get the warning, you have to look in the code what's wrong. So you can read more about client evaluation on this link. They have the documentation for all the features of Entity Framework core, so you will find the details there. Another part of Entity Framework is code first, and I'd like to mention one thing that was mentioned on many places, that the code first is actually not a good name. Because it doesn't mean that you have to write your C# model first before you even have the database. It should be named something like code-based modeling. Because it doesn't mean that you have to write the code first. It only means that the schema of the database is defined using a model in code in C#. So with code first, you actually have two options. You can write the model and then generate the database from the model, or you can take an existing database and scaffold your model from the database. So the code first is not a good name, but because it's not only code first, it could be also database first. But the important thing is that you have the code-based model in your application. Entity Framework core only supports the code-first approach. If you used the database first in Visual Studio in Entity Framework 6, which means that you create the ADO.NET data model, and you did something like create model from database, you looked for the connection string and have the diagram generated, the files with EDMX extension. So in Entity Framework Core, this is not possible. The diagrams are out, and you only can use the code-first approach. So also the designer for the ADMX models is not available for Entity Framework Core. So you have to use the code-first approach, which means that you can write the model from scratch, or you can use these tooling, command line or package manager console, to generate your model. So you can choose, if you are, for example, on Linux or you don't have Visual Studio, you can use the .NET command line tooling. So you can write .NET EF DB context scaffold and specify the connection string and provider name. If you are in Visual Studio, you can use the package manager console. So there is a new commandlet called scaffold DB context, and you specify the connection string, the provider name, which is the same name as the NuGet package for the provider. So it's Microsoft.entityframeworkcore.sql server. Yeah, same name as the NuGet package. And you can specify optionally many things like output directory or force to rewrite the actual model or something like this. So you can use it, and it will generate your model from database. There are some things in Entity Framework Core which are missing. So you cannot find the old object context API in Entity Framework Core. It's just not there. It's only DB context API. And there are many things which we'll see later in the roadmap which are not implemented. So if you like to use inheritance in your model, then only you can use currently the TPH, table pair hierarchy, which means that you will have all classes, all the hierarchy of classes in one physical table in database. The other types of inheritance are not supported yet. They will be supported, but Microsoft, I don't know how many versions Microsoft will even need to implement these. Also, if you are using the many-to-many relationships, M to N, then you can do it, but you have to define the table in the middle by yourself. So you cannot just create many-to-many relationship directly, that in one entity you specify the collection of the other entities, and in the other entity you will specify a collection of the first entities. You have to define the table which is in the middle of those entities, so that it will be a table with two keys, one pointing to the one table, the second. For each pair there will be a row. Also, the spatial data types are not supported, so if you were using geography or geometry types, these are also not supported, and also the lazy loading is not supported. You can use include, as in Entity Framework 6, or you can use a thing called explicit loading, which is something like context.entry load, and you specify the collection or navigation property you want to load explicitly. Currently, lazy loading is not there, and I think the team is considering that they won't include this feature, maybe never, because, or it will be switched off by default, because it can be very dangerous and it can hurt the application performance. On the other hand, there are many scenarios when the lazy loading is not a problem, but you have to be very careful how you use it. Also, if you want to use stored procedures, you can. There is a way how to specify your own SQL command and you get the results, but there is no direct support that you have a list of stored procedures and Entity Framework could generate functions for them. It's not currently available too. So these are features which are missing, but the core features, as you were used to, they are still there. So you can see on the right side of the slide, you can see a snippet of code, and you can see that the core things remain the same. So the link syntax is the same. The DB set, adding, removing records is the same. DB context has the database object, which you can use to send SQL commands to the database and such things. There is the change tracker object, which you can use to look out for entities which are changed, which are tracked or deleted or something like that. So you can see that the basic things like adding new records, save changes is there, link queries include everything. Everything is there. Yeah, but the lazy loading is not here, so you have to use include. Otherwise, the blog posts would be null. Yeah, so that's the only limitation in this piece of code. On the other hand, the including will be probably more efficient. Okay, so let's look at the demo, how it works, how it looks like in the project. So I have created a simple .NET Core application. I was trying the .NET Core 2.0 preview, which means that you have to install a preview version of Visual Studio 2017. So you can see the preview sign here, that I'm in the preview branch of Visual Studio. The good news is that you can install the preview and the stable releases of Visual Studio side by side. So on this machine, I have Visual Studio, the stable release, and the preview release. And it also have a little different icons, so you can recognize which version is which. So this project targets .NET Core 2.0. Yeah, you see .NET Core 2.0. And if you look at the list of NuGet packages, I can open the csproj file, and we can see that I have installed several packages. Microsoft Entity Framework Core, which is the base library, the entity framework. Then there is Microsoft Entity Framework SQL Server, which is provider for Microsoft SQL Server. Also, there is a package called Microsoft Entity Framework Core SQL Server Design, which contains the commandlets for the PowerShell console. So the scaffold, DB context, add migration, these are included in this package. Actually, these are included in the last package, the Entity Framework Core tools, but you have to have both of these packages because the commands are in the tools package, but their implementation for SQL Server is in the SQL Server Design package. So you need to have these packages installed, the base framework, which is the first one, provider for SQL Server, implementation of commands for SQL Server, and the commands themselves. Yeah, so these are the packages you will need, and I will go back. So here is my model. I have scaffolded my model from existing Northwind database. So the commandlet in the package manager console, the scaffold DB context generated the contents of this folder. So you can see there is a Northwind context, which represents the entire database. It derives from DB context, which is part of the Entity Framework Core. And for each table, I have the DB set like it was in Entity Framework 6, so that's the same. And there are some new things. The scaffold DB context generates the connection string for the database directly in the code. It's not maybe a good idea, but for development purposes, it's fine. And the if specifies, this if says, if the connection string is not configured elsewhere, we are using this. So in production, you can use the ASP.NET options or something like that, or environment variables to specify the connection string used in production. And in the code, you have the default one, which will be used by the developers. So this may work or not, but you feel free to edit this file. This is only what the scaffolder generates. And here is the onModel creating method, which contains all the metadata for the columns. It's also generated by the scaffolder, so you don't need to do anything. Actually, of course, you can It's for each table there is this section, so you can split it into multiple methods. Maybe to make this more convenient, this is one long method with 1,000 lines generated from the database. So that's the model, and if you look in at the entities, they are also the same as we were used from the entity framework 6. So you can see it's a partial class, so you can extend it, and there is a property for each database column. You can see we are using the standard .NET types, which are mapped to SQL Server types. So also here are the collections and navigation properties. They are not virtual, but because the lazy loading is not supported here, so there is no need to make them virtual. Sorry. And that's it. And also there is a file called startup.cs, and in this file we have configured the entity framework services. The new ASP.NET Core uses a mechanism called dependency injection, and you don't have to do it, but it's pretty convenient, so I recommend to do it this way. There is a method called configure services and object called iServiceCollection, and into this service collection you can register all services or classes you will need later. So I have registered an entity framework SQL server, which registers some base services for entity framework, and I'm also registering a DB context, and I specify the type, the Northwind context, which is the type which I want to register. What this actually means is that if you have a class in your project, for example, a controller or anything like that, and in the constructor, you add a parameter of the type that is registered in the service collection, the runtime will create an instance and supply it here in the constructor. So you don't have to create your own instances of Northwind context. If you do, don't forget the using clause. But you don't have to do, because you can only say in the constructor, I need Northwind context. And the runtime will give it to you. So because the constructor of this class is not called anywhere in the code, it's called by the runtime. And when the HTTP request ends, actually the Northwind context instance will be disposed automatically by the dependency injection mechanism. So you don't need to dispose, because it's configured that way that if you create it in the HTTP request processing, after the HTTP request ends, the dependency injection container will dispose it automatically. So you don't have to worry about the disposing it. If you create the Northwind context instance by yourself, calling new Northwind context, you can do it, but you have to dispose it itself. So the best way is to use the using block. And in this service, there is a method called getAllProducts, and you can see that the syntax of querying is the same. I'm not using the SQL link syntax, I'm using the lambdas. So you can see context.products.select and the lambda function which defines the transform. I'm selecting some objects called product DTO. DTO is an abbreviation for data transfer object, a plain object which holds the data. So I am just looking up for all products and order them by ID, and that's what I return to the UI. If I run this, it should display a page, and I've created an a simple HTML page which will display these data in a table. So after it starts, I'm attaching a debugger, so it takes a few seconds. So you can see there's ID name, supplier, category, and I'm using the data from my database. If you look at the query, I'm using the navigation properties in the queries. So I can say p.supplier.company name, and it generates the appropriate joins that are needed to get get these data. This is the same as it was in Entity Framework 6. If you have played with Entity Framework Core 1, you may find some bugs in these navigation properties in the select clause, because in EF1 it wasn't really stable. We have one application when it worked with .NET Entity Framework Core 1.1. When we upgraded to 1.1.1, it stopped working, and in 1.1.2 it started working again. So it was not pretty stable. Entity Framework Core 2 is much better, but still you can run into situations which are not working yet. However, we always, when we run into this situation in our applications, if you just rewrite the query and try to access the data another way, it will work. So there are some options how to do it. Sometimes you have to use some workarounds, but still it will work somehow. And I hope that Microsoft will fix these issues very soon, because it's not much convenient. So that's how it works and how it's configured. So don't forget to register it in the startup. You have to say services at Entity Framework SQL Server and add DB context, and this will register all the services into the service collection. In real apps, the database schema changes pretty often. So in previous version of Entity Framework, if you are using the diagrams, the EDMX way of working with models, there was a magic context menu with the button update model from database. Do you remember it? Yeah. Yeah, it was in easy scenarios it worked quite well, but if you customize your model, then the update model from database often overwritten your changes in the model with the new things in the database, so you will lose your changes. Sometimes it break up completely, so you had to delete all the model and import all the tables again, which means also that you have lost all your customizations. And the biggest problem was when two people in the team updated model from database and you got a merge conflict, because the EDMX file was a crazy long XML file with 3 models. There was a storage model, conceptual model, and mapping. So everything was 3 or 4 times in the file, and merging it was a nightmare. So you also deleted the whole file and scaffolded it again from the database. It was terrible. That's why Entity Framework came with the code-first migrations. Who is using code-first migrations? Okay? About half, most of the people maybe. Okay, so it works. You say add migration, update database, yeah, it's okay. There are a lot of things you can mess up. And if 2 people in the team create a migration and it merges in the source control, often you get also pretty complicated things, because the migrations in Entity Framework 6 have resource files with there, and in the resource file there is an actual state of the model, which is gzipped and base64 encoded. So maybe some people are nodding that they know it. If you look in the resource files, the model is compressed, which is bad because also you cannot merge it. So when 2 people edit migration at the same time and committed in the source control, then one of the migrations worked and the second one not, because the model wasn't correct in the resource file. So you had to also delete one migration and create it again. It was also not really convenient. So in many teams I have saw there was only one person who can actually modify the database, and other have to wait until he does the change they have requested to avoid these issues. In Entity Framework Core, it's solved because the model, the state of the model, is not gzipped. It's a C# class which can be merged. So if two people create a migration and you will get the migrations in the source control, you will get merge conflict. But you can resolve it because if one adds one column, the second one at the second column, auto merge will handle this, and only in few situations there will be some things where you have to remove your migrations and create it again if the two people worked with the same table and did really conflicting changes. So this will be much better, and the package manager console commands are the same. However, some parameters was changed. So if you are used to use update database minus target migration, now it's only update database minus migration. And also there is a new command called remove migration, because when you remove a migration you have to adjust the model which is used to detect changes. So it's not exactly the same, but it's very similar. If you don't have Visual Studio or if you want to use command line, there are alternative way how to do it. You can say .NET EF migrations add and do it from the command line. So there are two ways how to do the same thing. Let's look how the migrations work. So I have my model, and I have already created the first migration. I have typed add migration initial create, and because I haven't started with an empty database, but the scaffolder doesn't know it, so this initial create contained all the tables in my database. So I've removed them because I'm not starting with an empty database. I already have my tables here. So I have created this migration, and I have just removed everything which was in the up and down methods. So that's the start. And sorry. Now I can add a column somewhere. So I have chosen one random table. I have to add new column, my new column. And now I can generate a migration, so I say add migration, orders, my new column, edit. That's the name of the migration. And it will create migration. If you mess it up, you can use remove migration, which removes the last migration you have created. And also, you can see in this folder, there is my new migration. So if you look in this migration, actually I have one column I added before this session, so there are two columns actually being added. Products is deleted and orders my new column, but it detects changes in the model and generates migration. The down method deletes those two columns. And there is a file called Nordwind context model snapshot, which is the file I was talked about. It's a complete snapshot of the model. So the migration framework detects changes because it compares this snapshot with your actual model. So if you look in this context model snapshot, it's a file which contains a description of the entire model. So you can see categories, all the properties and stuff. And if when two people add migrations, this will add these files. So there is this class, this new file with the migration, and also it changes this file. So if you commit this change and the other one commits his change, there is very high chance that the auto merge will merge this model snapshot correctly. So the migrations won't break and everything will work as it should. Yeah, so that's a very good thing actually, because it's not one long gzipped base 64 encoded value. It's a normal text text file with C# syntax, so you can merge things quite easily inside this file. Of course, if you do a lot of changes, if you rename some tables, it can create conflicts, but you will be able to manually resolve them, and only in very few cases you will have to actually remove these migrations and create them again. So I think this is a nice change they made, because finally the migrations will be useful. And of course you can say update database. If you want to generate a script, in previous version of Entity Framework you would just add the script option here. But they changed the syntax, so now this doesn't work, but what works is script database, and it works. So a lot of tiny changes, but still it's not such a big deal. So I can say update database, and hopefully it will work. Yeah, you can see also the SQL commands which were sent to the database. You can see alter table products, add is deleted, blah blah blah. Yeah, and also there is a table called EF migrations history, which contains a list of versions of migrations that were applied to the database. So the Entity Framework knows which migrations are already in the database and which are not. So that's migrations. If I want to revert these changes which I've made to this demo, I can copy the name of the migration and and say update database migration, and not this, I need the initial create. So this name, and it will revert my changes back, so it removes these columns. You can see it's looking for some constraints, and then it's dropping columns. And now I can remove the migration. Do not delete this last migration because the snapshot wouldn't be regenerated. So don't delete migration files. Use remove migrations for it, because it will also refresh the context model snapshot. Yeah. And now if I remove this column, and from the products the is deleted, I will be in the correct state now. Yeah, so that's how I can revert these things. Entity Framework Core comes with a lot of database providers, so you can use other databases except of SQL Server. SQL Server is of course the preferred one, but if you want to use SQLite, Postgres, MySQL, SQL Server Compact Edition, IBM or in-memory database, Oracle, which is not supported officially, but there is an unofficial provider for Oracle for Entity Framework Core. So this is the list of providers. They also announced the non-relational providers, but they are not working yet. But you can, in the future, you will be able to use Redis, Azure Table Storage, and many other data sources. I'd like to show you the exactly same application running on Linux and with other database provider. So what have I done? I have just took this application, make a copy, and change the NuGet packages. I have I have it here. So if you I have the same application twice. One is with the SQL Server suffix, one is with the SQLite suffix, but it's the same. The only change I made is the NuGet packages. You can see I have changed SQL Server with SQLite. That's the only change. And I also added a file Northwind SQLite, which is SQLite version of the Northwind database. And the problem is that the context is not the same for the database providers. So I have reshuffled the model from the database. Yeah, because there are some changes, some different types. Also, the schema of this SQLite is not exactly the same like the SQL server. But if the schema is exactly the same, it would be you would be able to use the same model. But each database has its own differences, so it's not always possible. So if you want to target multiple database engines, you will probably need more context objects. The entities can be the same, but the context will be probably different. And I've only changed the connection string. And if I log in to my Linux machine running in Azure, which is this one, I'll copy this IP address. So I can log in to my Linux machine. I will make the text larger. Oh. Appearance, change, yeah, that's it. That's it, so I will make it larger so you can see it better. So I'm in my home directory. I have a folder called efdemo. And it's the same thing. There is a folder and the solution file. So I can go here, and I have my project here. So I can only run .NET Restore. I've already done it, so it should be quick. It only verifies that the NuGet packages are in the NuGet cache. And now I can say .NET run, and I have to do it under the using sudo, because I'm binding to port 80, which you cannot do if you are not admin. So I say sudo .NET run, and it will just run my web application on the port 80. And when I minimize this window and open this page in the browser, it'll take a couple of seconds to start. The first request is always slower than the other ones. You can see the other ones are immediate. So you can see that the same application works with SQLite on Linux. Yeah, so exactly the same code. I only changed few NuGet packages and connection string. So that's how this application runs on Linux. And Entity Framework Core 1.1 brought several new features. So the link translation, it's improved, they can say it in every release, because it gets better, it actually gets better. There is also connection resiliency since EF Core 1.1. The connection resiliency means that, for example, if you are running in cloud, then they sometimes need to migrate the database to other server. And the connections are not reset. So the resiliency is something like a retry logic for database connecting. So if the database cannot be connected, the connection resiliency, if you configure it, it will try again until it gets connected to the server. Because sometimes the load balancer just the connection is already open, and if the database is moved to other server, the connection times out, but it takes several seconds. So if you connect just in the time when the database was moved, but the connection still exists, it will get a problem. So connection resiliency can fix this. Also, there is explicit loading. In the first version, even explicit loading wasn't there, so you only could use include. Now in EF Core 2.0, you can use explicit loading and include both of them. dbSetFind is also a handy function which will give a primary key, and it will look up for the correct entity. There is also API to check what changed on the entities. So there is, for example, get modified properties, get database values, which will load current values for your existing entity, and you can see if the entity was changed or something like that. And EF Core 2.0 also improved link querying, and I have copied these things from release notes because they are quite interesting. Sometimes the old versions of EF Core didn't create, or they created a lot of subqueries which weren't required, so this is optimized. Also, EF Core used sometimes client-side evaluation, even if it shouldn't be like that way. So they already fixed it. And also, the select was quite, if your link query ended with select clause, the Entity Framework Core sometimes fetched all the columns, not only those you required, but all of them. So also, it wasn't pretty efficient. Now, these all things are fixed. And also, there was some problem with n+1 queries, so that's also fixed. So they are still improving the querying mechanisms. So I hope we will soon be able to use this in the advanced scenarios. Also, there are some new things, like if you want to use the like function in SQL, and you want to use it also in the in-memory provider, it wasn't possible, so they implemented the ef.functions.like, which you can use. It translates to SQL like, and also in the in-memory provider, it will be evaluated, so you can test these expressions. But of course, don't forget that in database, it's driven by the collation on the column. In memory, it will work in other way, but still it will translate even to in-memory query. Also, Entity Framework Core didn't support complex types, but EF Core 2.0 brought a new feature called owned entities, which is something like context type, but Entity Framework tracks the identity of this object. So even if it doesn't have its primary key, it's tracked. So it's quite a good idea, because sometimes you can use one-to-one relationship between those types. So it's a good thing that this object is tracked. Also, you can split the entity to multiple tables. And very nice feature is actually global query filter. In the model configuration, you can add query filter to an entity, and on all places where you query the table, this filter will be applied. So I have a demo for it. In the Northwind context, I have actually done one change, query filter, and in the order details table, I have created a query filter, and I am only displaying entities which have discount column equal to 0. So if in the product service I have another function, I'm selecting the products, and now I am doing sum from order details, and I'm interested in knowing how many items of this product were ordered. But the query filter will filter the order details collection use only to the records which have discount equal to 0. So I will not use all the data, only the data which match the query filter. Yeah. So you can use it, for example, for the is-deleted columns in your tables and such things. And if you, in some places in the application, want to ignore the filter, you can say ignore query filters, and you will get all the data without respect to the filters. So that's quite a good thing. The only thing that's not implemented yet is that you cannot use navigation properties here. It would be very useful to be able to touch, for example, the order. So I could say e.order.something, but that's not currently supported. I hope they will add it soon, because this would be very useful, because you could do, for example, user permissions using these query filters that you can use. You can somehow give their ID of currently logged user and filter only the data he actually can see. Yeah, so that's quite interesting feature. I hope they will add support for navigation properties here, so you can do, for example, role-based checking or something like that, because that's very strong, powerful feature that would simplify many things and prevent you from making a lot of mistakes. Also, there is a DB context pooling, so you can reuse DB context objects. You don't have to create them new instances. And also, there is a function EF compile query, which you can use to pre-compile query, and then you can use just this query. So this will help the performance because you can use this compiled query object, which is created, and you just call execute, and you have your data without translation. We have seen the query filters, and the last slide, the biggest question: to upgrade or not to upgrade. When you should use, or when you should consider using Entity Framework Core. I would be perfectly okay to use it in simple applications where I have several tables in my database, not much complex relationships, and limited set of queries. If you have a big ERP system where users can filter with each column and there are complex relationships, it's not ready yet for these big applications. But for smaller things, it's okay, it works. There are some issues, but you can work around them somehow, so it's not a problem, and it's open source, so probably you will be able to report this issue and they will fix it in the next release. With Entity Framework 6, if you have application which uses Entity Framework 6, there is no need to upgrade. The syntax for querying, for inserting and deleting didn't change, but stay with EF6 because a lot of things which are supported by EF6 are just not in EF Core yet, so you need to wait. But it actually doesn't matter because EF6 is here, it's stable, it's well tested, and everyone is using it, so there is no rush, wait until Entity Framework Core is more stable. And finally, the list of features, just to show you that this page exists. It's in the docs microsoft.com/ef, and there is a table which lists all the features, and you can see what's in EF6 and what's in EF Core. They didn't update it to EF Core 2.0 yet, but they will soon, I hope. So you can see that, for example, the inheritance table per hierarchy is supported in both. Table per type, table per concrete class is only in EF6 now. So review this table if you want to know which features are supported and which are not. And if you want to try write new application on new platform, maybe to run it on Linux, then Entity Framework Core is quite usable. With some limitations, you have to be aware of the restrictions and limitations, but I wouldn't be so much afraid of using it because every technology has their issues. So I believe I have shown you some introduction into EF Core. If you have any questions, I will be in the discussion zone now, so feel free to ask me. I'll be happy to answer. Thank you.